Hi, everyone. Welcome. I'm super excited to be here. My name is Julia, as you can see on the screen. I'm a Principal Developer Relations Engineer at Dash0 as of 1 week. But I'm really happy to be wearing this red jumpsuit here. You're going to see us all over around at KubeCon. Stop by our booth if you want to grab a backpack. And my brilliant friend and co-speaker, Mauricio Salatino, a.k.a. Salaboy, he couldn't make it to KubeCon, unfortunately, but he's still going to help us and enlighten us with his knowledge throughout the presentation. Now, today we're going to talk about something I think every platform engineer has struggled with, which is how do you actually stitch together all these open source projects that our friends, builders, maintainers help maintain throughout in the CNCF ecosystem, and how do we make them work together and deliver real value for developers? So before we dive in, a quick intro about us. We are both CNCF ambassadors, very involved in the Kubernetes and cloud-native communities. I organize some events in New York. If you're ever there around the area, hit me up. We'd love to grab some coffee. And we wanted to, I was talking to Mauricio, what are we going to talk about at KubeCon? What are we going to submit? And we wanted to give this talk because we've seen the same thing over and over again happening. You know, we have amazing tools out there, but there is a lot of confusion about how they fit together, because they do fit together at the end of the day. Mauricio, let's see. Oh, wait, no sound. Oh, okay. So Mauricio, he was just saying, he recorded some snippets. He was just saying he was really sad that he won't be able to make it to KubeCon, and he hopes to see everyone in Amsterdam. Okay. So to understand how all these pieces connect, we first need to be clear on what platform actually is and why it matters, how it drives value. So at its core, platform engineering, it's about designing, building, and maintaining systems that automate infrastructure and streamline software delivery for developers. And they do it through what we call an internal developer platform. If you look at the pyramid on the slide, you can see how it connects pretty much everyone in the organization. So from infra and ops to platform engineers to developers to managers, and even if you think marketing, finance, because at the end of the day, if developers are shipping fast and being productive, it helps the whole company. So at the bottom, you have the pane, which is ticket ops. When developers, they have to open a ticket every time when they need something from the infrastructure team. Waiting times, they have to wait for that, and manual reviews. In the middle, we drive value through standardization and automation. And then at the top, that translates into what I said, the benefit to the whole company. So you have faster time to market and business impact. Now, let's have a quick reality check. Tools should serve people and not the other way around. You heard that clearly. Tools should serve people and not the other way around, not people serving tools. And in the cloud-native world, there are so many tools to choose from. You've seen the CNCF landscape. It's overwhelming. And this is just a small image. It's actually bigger than that. And sometimes we start adopting tools because they're cool. People are talking about it. Because a friend told us about that tool at KubeCon, rather than because they solve an actual problem for our developers. The mindset shift we need is to treat these tools as means to an end. So it shouldn't be the goal just to use that tool. Every decision we make when we're going to use a tool, we should ask a question first. Does this actually make our developers' lives easier, better? You know, so this is the question we should all ask. And of course, getting there isn't easy. Platform engineers, they face a pretty unique set of challenges. So first, we need to support developers without becoming bottlenecks. It's a fine balance between enabling teams and creating another gatekeeping process. Because if you create something that they don't like, they're gonna find workarounds. If you're a developer, you know that. They're gonna create their own scripts, and they're not gonna use the platform. Then you also have to scale infrastructure without scaling complexity. Every layer of automation introduces actually more moving parts, and that can easily spiral out of control. But again, you want to reduce complexity, but also it can't be too simple. You can't hide everything under the hood, because otherwise developers, they're gonna just see everything as a black box, and they're gonna stop trusting the tools that they're using. So there's a fine balance between everything. And then there's stability and security. We need to ensure the systems are robust and compliant while still being flexible enough for experimentation, so developers can break and try without breaking actually production. And finally, we need to empower teams with self-service. Giving teams autonomy is crucial. They need to be able to choose if they want to use that. And you also need to build that with governance and guardrails. But also, you can't force them to use it. Because once you tell them, you need to use this platform, you've lost the developers. They need the autonomy to choose if they want to use it, yes or no. Now, Salaboy had something again to say, but teams, they should enable other teams to use better and reduce complexity. So platform teams, they need to understand what the developers are doing and the tools that are using and their workflows. And the best way is to understand that. We're going to exemplify. So we kind of built a scenario. So I think everyone understands better when it's something real. And to visualize that, we imagine we're running a hospital. And there are several teams. There is the platform team in the middle. It's pretty small, only a few engineers, and they support many departments in the hospital. So imaging, pharmacy, research, surgery, etc. And each of these teams, remember, it's a fictitious scenario. Each of these teams, they're building applications. So applications for doctors, for patients, for nurses, etc. And they all have their own workflows, their own systems and priorities. And the platform team's mission here is to enable all these departments to move faster, securely, and on the same foundational platform. So one internal developer platform, all without reinventing infrastructure every time. So let's see how we can use some of the CNCF projects to help us with this internal developer platform. Let's start with the surgery department. So they're trying to build an application that pulls patient data and imaging results from different systems from the whole hospital. But they can't find where the APIs are and who maintains them or even how to request access. They've been messaging on Slack, the platform engineering team. They need that information ASAP. So the platform team publishes all the internal APIs and services in Backstage. Now, every service has its documentation, dependencies, and health checks right in the catalog. The next time the surgery team opens Backstage, they simply search imaging service, for example, or if they need something else, they just search on the search bar, and they will immediately see the available APIs with complete metadata, their endpoints, and who to contact if they have any questions. They integrate the data into their pre-op application within hours and not days, not having to wait for anyone else to give them access to something. And Backstage really gives visibility, ownership, and self-service to the developers. It's like pretty much the internal Google for the developers in running their applications in production. And adopting Backstage can be daunting at first, so I'm gonna try to dub Mauricio. And it requires platform teams to really learn how to extend and create Backstage plugins. But once the teams figure out the process, it becomes very easy and helps the whole organization. So you can create advanced integrations across third-party tools and internal systems. And all these integrations, they reduce the cognitive load of team members, which don't need to access separate UIs anymore. Now, let's look at another challenge that one of the departments is facing, the emergency department. Now, they don't struggle with code. They're great at coding, but their challenge is packaging it, configuring Kubernetes, and deploying it safely. each department in the organization, in the hospital, they are doing things differently, and the platform team is going crazy. They're spending hours helping every new application get off the ground, every new team, and they can't really focus because they're stopping fires left and right. So the platform teams defines reusable application templates using KubeVela. Developers now, they just describe what they need. Let's say if they want a web service or a database, and KubeVela will handle the rest. KubeVela pretty much turns that intent into a running application, applying policies and best practices automatically. Now here's what that looks like. KubeVela gives you a clear view of how applications, how it flows. So from the initial application definition to the cluster, deployments and services, everything. And everything is automatically managed and tracked. So it also connects CI pipelines, GitOps tools, cluster into one clear model. So this, being able to visualize that helps a lot and removes some of the friction. So the developers now, they can focus on what they want. They just ask for it, and they don't have to, think about how it's going to be deployed, because KubeVela is doing that for them. And again, everything is policy-driven, self-service, and it standardizes the application delivery across all the departments. So it's very helpful. Now, developers care about their application and the infrastructure that's needed to run by these applications. By using KubeVela, you can bridge that gap between how developments think about their application and the low-level, the operation part of Kubernetes in this world. Now, let's look at another challenge, the pharmacy department. The pharmacy department is managing a prescription application tied to a patient data and lab results. So they're collecting all that. But they're deploying all the updates manually. So if something breaks in production, they have to, do it manually again and again. And all the configs, they are inconsistent between the environments. So this is a real nightmare. The platform team, to help them and to help themselves as well, they introduce Argo CD. Probably most of you have heard of Argo CD here. It brings pretty much GitOps into the workflow. So every environment, from dev to staging to prod, now it's synced automatically from Git. And you can see the status there in real time in the Argo dashboard. So what's synced, what's out of sync, and what's failed. And Argo CD pretty much continuously reconciles what's running in the cluster with what's declared in Git. So you don't have to do any more manual commands, kubectl. There are no drifts. And there is a full traceability for compliance, which is very important depending on what your organization does. Hospitals, they definitely need that. And that's pretty much GitOps in action. So Argo CD, probably most companies use that, organizations, and it really helps the platform team for all this GitOps part. Now, we have to talk about AI. AI is everywhere, and it's not a buzzword anymore. It's part, there is a co-located here just for AI, and we needed to introduce AI somehow, and there are some projects, and even now they just talked about it. That's why we're going to just briefly mention about K-Agent, how K-Agent can help the platform teams. So it provides a Kubernetes native way to create smart agents, and that can help you to manage, troubleshoot, and debug your Kubernetes clusters, but also the tools that you're already using inside your clusters. So K-Agent allows you to define agents by describing the agent responsibility using a prompt-based approach and connecting agents to tools using MCP servers. So for the hospital platform team that we're talking about, we can create an agent that uses KubeVela, for example, and Argo CD resources to answer questions. So about the status of a specific deployed application, or to troubleshoot issues with project-specific configurations. Now, after installing KAgent using Helm, for example, you get a really nice dashboard, as you can see, with some quick starts and a set of deployed agents. There is an agent that was designed to understand Kubernetes. And because it is running inside your cluster, you can ask questions about your application and the cluster state as well. It can also perform actions for you. So like if you need to update applications or configurations, it does that for you. And there is an Helm KAgent that was created just to understand Helm deployments. So there are so many things KAgent can do, and you should definitely go and look at their documentation. KAgent is built on simple concepts of agents and tools, where agents are autonomous systems that can plan, execute, and analyze your clusters and the cloud-native projects installed. Agents, they perform actions, including retrieving information using tools, which follow the MCP protocols. So with KAgent, you can quickly define a new agent by describing the agent goals and missions, and using a prompt, it will provide the agent with a list of tools that it can use to achieve those goals. Okay, so you can, now we have another challenge. So several challenges inside this hospital. Now, the imaging team, every time they need something from the infrastructure team, they need to create a ticket. So for instance, here, they need a new bucket or anything else. But they open a ticket, they're waiting for days for someone from the infrastructure team to provision it, and it really slows everything down. With Crossplane, the platform team just exposes the infrastructure as APIs. So the developers, they can just write a YAML, like a storage.yaml file with what they want, or they can ask KAgent to do that for them. And the agent will create the YAML file, commit it to Git, and Crossplane will automatically provision that. So here, this diagram, you can see how Crossplane really extends the Kubernetes API to manage any kind of infrastructure from your databases, storage, networks, or even full cloud environments. So instead of going directly to AWS, Azure, any other place, you just do kubectl apply, a Postgres instance or an S3 bucket, and then boom, it's created for you. Crossplane just everything becomes another API call. Okay, so let's recap. Salaboy is here to help us. Now we have a unified dashboard and an application model that the developer teams can use to deploy complex setups. We've seen so many setups, so many applications being deployed. And we can use GitOps to smoothly release new versions of our application to different environments. We also have agents that understand our applications, our clusters, and the tools we're using to troubleshoot issues that come, and also to help us deploy these applications. Now, this is all great for the platform team, but we need a way to glue everything together. So how are we going to do that? Here's the case, how we're gonna orchestrate everything. So really a flow that connects all these moving parts we were talking about. And for that, we're using Dapper. So Dapper workflow can help us build durable workflows that guarantee a set of tasks are executed in completion. So imagine the imaging department, for example, they deploy a new version of their application, and now they need to provision a new S3 bucket to store the metadata from each patient. We can use the tools that we described before, but the coordination between those tools can be orchestrated by Dapper workflow. So this ties everything together. The platform teams, they can define long-running workflows using a workflow as a code approach, as you can see here, to perform the orchestration across different tools. So they just define the workflows, and it can monitor each of the workflows execution all on Dapper. And for our use case from the hospital team with each department, we can consider this workflow that involves providing infrastructure, updating manifests so Argo can roll an update, and then also using an agent to make sure that the new version is working as expected. And also, we can even use the workflow to notify teams about the successful upgrade. So if for some reason GitHub is down, let's say, we want to make sure that our workflow runtime keeps retrying until all the steps are completed. And even if the infrastructure fails, for example, GitHub or AWS, we saw the other day there was an outage, the workflow runtime will keep trying to complete the tasks and not just fail like a CI pipeline. So notice that these workflows, they can include external events and human loop iterations. Great. So if you haven't checked Dapper workflows or Dapper in general, I recommend also great documentation. All these projects, I think I encourage you to go talk to them at the pavilion here in the Expo Center. People they really want to explain and get you to use, to contribute and help. Now, last KubeCon in London, Salaboy and we presented a similar talk about some CNCF projects, but focused mainly for developers. So if you're a developer in the room, feel free to check out the recording of this talk. Also, Mauricio, he has written some books, so he's like brilliant, and I have these books, so I can't talk enough about them. And I'm also giving a few talks later today and throughout the week. If you want to come see me, I would be glad to have you as in my audience. Also, would love to have a chat with you. And again, if you want to connect with us, Mauricio, thank you for trying to help us. We miss you, and we'll see you in Amsterdam. Take care, Mauricio. Thank you.